Oh, I suppose this has started. People hear me? I suppose. Yep. Okay, so welcome to the Galaxy Code Architecture training. If you haven't checked out Discord yet, here, I suppose I should show my screen. Just the window. Do that. I put a link here to the YouTube I created for this training. Well, we do this training a lot, or like once a year. And last year's was pretty miserable because we didn't update the slides, etc. So this year, I had a little less going on than normal. And so I took time to completely rewrite the slides, re-segment out the tutorial, and make videos for everything. So here's the YouTube playlist. It sort of goes over things that we could potentially cover. I think that we'll only be able to get to a subset of this today. But I think what we're going to probably not have time for is the ecosystem at the start, which is a discussion of, all the different projects that sort of are related to Galaxy but aren't the Galaxy core code base. We probably also won't get to the web client at the very end, which is the last topic I covered. But I think we'll get through this middle chunk of stuff. So we'll start by talking about project management, how to contribute to Galaxy, right? So I think this is probably a more interesting topic. Probably a lot of you are here because you want to sort of start contributing, and that's sort of covered here. I'll briefly talk about some principles around Galaxy code architecture, files and directories, the physical layout of the code base, a web request, what happens, how the servers interact, and then the meat of the back end is models and managers and pluggable components. And so these are just various backend components and their architecture. If you have any particular questions during the talk, I think probably I don't love this. It's hard to get my attention, but maybe Discord's the way to go. But if I miss something in chat, Nate or someone else who can host should probably take over and yell at me. So do try to interrupt with questions. The videos are all here, right? So if there are no questions, then this is just a waste of everyone's time. Yep. So we got the Q&A panel. Place to do that also. Or Discord is great too. I guess I should just, it's so quiet. This is so eerie. This is, I'll just jump right in. Okay, oh yeah, I should mention in the room itself, on the side, oh, no. On the sides, there are links to the documentation and the links to the videos. So, but we're in presentation mode, so you can access those. Yeah, let's just get started. Wait, should I turn off my video, I suppose? Can I turn off my video but keep sharing the screen? Does that work? How do I get the share screen to be? If I expand this for me, oh, no, that's not right. I can't hear you, Nate. You're muted.
Oh, better now?
Yeah.
So so for people to be able to see your screen share, you can either full screen that screen share, or they can pinch to view it, to zoom in on it.
Oh, so they can just do that on their end?
Yes.
All right, awesome. Thanks. Yep, okay, great, thank you. All right. All right, well, I'm just gonna get going. Welcome to the Galaxy Code Architecture training talk. These slides are on training.galaxyproject.org. Please interrupt. Catch us on Gitter anytime. Find us on GitHub. Normally I go through in this talk, but I don't think we have enough time. All the different projects, there's a million. And please tweet. If you tweet about Galaxy, use the #Galaxy hashtag. Find us on You can find our project account at Galaxy Project on Twitter. So this is the section I'm going to skip about the ecosystem, but it's a great ecosystem, wonderful assortment of just like various, like a wide assortment of different people who have different roles, and scientists and developers and people who are hacking on the API and people who are hacking on the front end, and it's a wonderful community to be a part of, and I definitely recommend checking out that video. But I think the project management piece is a little bit more inscrutable. It's probably worth talking about before we get into the actual code architecture, because a lot of this is pieced together in various places, and it's not really clear the sort of social architecture of a project until you really get used to it. So hopefully this video can sort of serve as a sort of getting going guide with contributing to Galaxy Project Galaxy, the main code base. So we have a quick start. I think there's not a lot in there other than the stuff I'm going to talk about today. I'll start by talking about pull requests. So nearly all changes to the Galaxy code base should come in through pull requests. Yeah, so we make a couple exceptions for this, and these are exceptions that probably won't apply to you if you're watching this video, because it's for the committers. But these exceptions are for security patches, things that we don't want public until we're ready to release them, packaging and release process artifacts, and then we will occasionally backport fixes from dev or a stable branch to older stable branches. Speaking of security, we have a security policy. If you go to Galaxy, here I'll bring up a Galaxy. Security policy is right on the top here. Thanks to Helena. Oops, no, don't do that. But in the very brief summary is, if you find a security issue, please email us directly rather than posting it on a public forum. So what do we do with security issues that we encounter? We sort of have a procedure in place that someone will acknowledge the security email within 2 business days, and then we're pretty good about putting resources behind fixing it. We support basically a year's worth of Galaxy. So it's kind of laid out here, but like right now, if we got a security patch today, we'd probably go back to 1909. Yeah. There are older branches that we sometimes patch, but we have no policy of like formally agreeing to patch them, if that makes any sense. We sort of, it seems formal because it's in a document here, but it's a little bit nebulous and informal, but we have a severity quantification of issues. So there are issues that we treat as very high, and these are get that full support back to a year. This is remote code execution, SQL injection, cross-site scripting, and then any issue that allows user impersonation. Sort of medium or lower severity issues would be stuff like with really uncommon configuration options, unvalidated redirects or forwards. Yeah, and there's obviously all sorts of security issues that don't fall in between these 2 levels, and so we sort of take those on a case-by-case basis. If you're letting us know about vulnerabilities, please describe the issue in as much detail as you can, and your setup, the versions that it affects, and if you have a patch, how to patch it. That would be amazing. And then we also let us know like your institution and name and such, because we like thank you during the release process and sort of give you credit for finding the issue. It's been a while now. There were a few years there where we had a pretty consistent set of security issues that we were patching, but it's been a while, which I think is probably a good thing. We're getting better about testing, but I mean, it's a huge code base with a lot of different pieces. So this is not mean, this is definitely something to still know about. So I've mentioned branches a couple times. So I just wanted to talk about what those are. Because again, just landing on Galaxy Project Galaxy, maybe it's not clear. I mean, it's certainly not clear what the different branches are. And so if you land on Galaxy Project Galaxy, you land in the development branch. So this is the default branch, dev. And this is where most active development happens. And so if you're adding new features to Galaxy, opening pull requests, it will probably be against dev if it's a feature. We have a master branch. It references the latest stable branch. Generally, though, that I don't really recommend it as a deployment target, because you probably, when you're going from 2001 to 2005, you want to know that you're doing a full point upgrade. So I wouldn't target master as a deployer, and I certainly wouldn't target master as a developer, because your patch should patch an actual targeted release branch. So master is largely unused. It's used for stuff like Planemo, where we want like a target, like a default target for a stable thing, but it's not of tremendous interest. And then the release branches are based on the month that they were released and the year, sort of Ubuntu style. The latest one is release 2005. Yeah, and if you have bug fixes you're contributing, by all means, open them against the release branch that is of interest to you. Otherwise, open them against dev and just let us know that you want to backport it. We're pretty good about, backporting development bugs for new contributors. Yeah, and so there's a bunch of releases backwards. Yeah, and as you can tell here, it's about 4 months between releases. It's been pretty consistent for a while now. Committers and yeah, Nate or whoever, just like pop in if there are questions in the chat and just let me know. So all the repository governance of that repository is done via pull requests and voting. And so it's not just open source, it's open governance. And I think we're really proud of this fact. So the sort of the group in charge of managing the open governance process is the committers group. And the committers group is a group of trusted developers and advocates who manage the core Galaxy codebase. The Galaxy project committers are the only individuals who may commit to the Galaxy core codebase, and so these are the people who are merging the pull requests. It doesn't mean that you shouldn't look at Galaxy pull requests, though. So if there's a component of Galaxy you're really interested in, or you want to get if you want to get into the code base, a great way to do that is to look through pull requests and comment on them and make comments, make suggestions, run the tests, and make sure they work, etc. So while you can't pull the trigger and merge a pull request, you can be instrumental in the sort of process of getting those pull requests like processed and merged. I mean, that's a lot of work. It's a lot of pull requests that come in every day. And a small group of committers. So yeah, I would definitely suggest doing that, especially for things that you're interested in.
Peter Briggs asked if release branches continue to be updated after a release is made.
Yeah, so the release branches do continue to be updated, but with bug fixes only. And so release 2005 will change over time. So you will get new bug fixes and new security patches. We won't add new, I can't recall a time, for instance, where we added a new database migration or a new, big change to the UI. So we have smaller things that are meant to be the kinds of things where you could just tell your Ansible role, just target 2005. Maybe there'll be some new commits incoming, but I don't necessarily care to test them. Now, if you have a setup where you have a test instance and you have a suite of tests you can run and automate all that testing, by all means, do that before you do that. But I mean, most people don't. And so they're designed to be updates that aren't too difficult for the admin, if that makes sense. I certainly don't recall a database migration happening after a release. We've made like small changes to the UI, but nothing sort of core that I can recall. So it will probably be transparent to your users. I mean, unless it's a bug fix, and then not transparent in a good way to your users. Now we do actually tag. We don't do a great job at this, but there are actual tags for the releases. That is like that release frozen in time without the bug fixes and patches. But
the tags are pretty useless because we never tag point releases after the release. So at some point we need to start doing that, but I wouldn't use the tags. Also, the things that go to the release branch are required by policy to be bug fixes. Now, people have gotten creative before about what they claim a bug fix is, but we tend to only let things in if we're relatively certain nothing's going to break.
Yeah. Oops. I'm bad at computers. Should I have my camera on? It doesn't matter. Thanks for the question. So yes, by all means, look at PRs, comment on them. And if you want to be a committer someday, this is like, oh yeah, that was my other point. Like that's like, it really helps the committers to know like, oh, someone tested this and it works. So that kind of comment on a PR is like a real like relief if I'm someone merging the PR. If two people have looked at it, then it's much easier to review. Committers may participate in formal votes, including votes to modify team membership, merge pull requests, modify policies, etc. Committers have a lot of power because they can veto any pull request. So, I mean, everything comes in through pull requests, and any of them can be vetoed. So that's a lot of power. We have a code of conduct that describes expectations, encourages diversity, and describes how to report issues to such behavior. We have an open PR that's going to change it a little bit right now, but the reporting is going to change, but the actual content of the PR is the same, or the content of the policy is the same. So we encourage everyone who's contributing to be friendly and patient, be welcoming, be considerate, be respectful, be careful with the words that we choose, and then try to understand when we disagree. It's like a fantastic community, and there are people there are times I've had disagreements with people, but I mean, everyone I've disagreed with had legitimate reasons for, on both sides, like why we disagreed, and it's definitely worth trying to understand why that is happening. And the reporting, right now it says to report to Dave. We're going to sort of expand this out so you have more reporting options. Yeah, just so you can feel comfortable with just having more options for who to talk to if there are issues. That should be out by next week. So the release process, I mentioned that there are new releases issued every 4 months. The process is largely guided by an auto-created self-documenting release issue. And so here's the 2005 release issue. So there's a release manager, and for the last few releases, it's been Marius. He's been doing a good job, great job. So I'm just going to walk through the release issue real quick as like a documentation of what the release process is, if that's interesting.
You might want to font size on that a little bit.
Oh, okay. I'm not good at computers. How do I do that?
Yeah, that's good.
Thanks. So we pick a freeze date. This is kind of this is always anyway. With the freeze date is the beginning of the month that we do the release, but sometimes we'll try to push it ahead of time because the release process takes a lot longer than a month. So probably we we froze before May, and we didn't get the release out until June. But there's a checklist for that. We make sure there are no blocking. When we first create that release branch, we call that the freeze. No, yeah, that's like we're saying no new development is happening on that branch. There's bug fixes, but we don't add new features, and that's at the freeze point. So we ensure that there are no blocking PRs at that time, and the release issue creates a link to what would be blocking, and there's a make file target to check that. We make sure that everything is merged up, so that the release freeze of 2005 has all of the fixes that were in 2001, for instance. And then we actually do the freeze, and so it creates a branch, it modifies Galaxy's version, etc. And then we update the milestone of all PRs. So all new PRs will be milestoned with the next release. So when we froze 2005, all new PRs had a 2009 target date. And that doesn't mean they all are merged in 2009. As part of this, like ensuring there's no blocking PRs, sometimes that just means pushing off PRs we're not ready to merge yet to the next release. So there's no like promises like, oh, if I get my PR done in April, that it will be in May's release. Because, I mean, yeah, there's just no promises there. PRs are scary. They can break things. And then we set the branch as protected. Then we assemble issue to review timeline notes. I see. We make sure there's no security, we synchronize with our security process here so that we make sure those fixes are in the release and we have a plan, and that's sort of the release manager's responsibility. Pretty much right after the freeze, we try to update test.galaxyproject.org and the test tool shed. This isn't always done right away, but within a week or two, usually. And then we deploy the release, and the release note says within a week. Yeah, I mean, I think lately we've been pushing this a little bit. It's been maybe 2 weeks after the release. We'll push it to usegalaxy.org, or not before the release, before the freeze. But it is the case that usegalaxy.org will have the new release on it well ahead of the actual release, so that we're catching as many bugs as we can before we send it to you. I mean, as admins and developers. I mean, and so our users are guinea pigs. Then, yeah, we deploy to the toolshed, similar timeline. We update, so BioBlend is the API client for Galaxy. I cover that in the ecosystem talk on YouTube if you want to see it, hear about it, or probably if you're in this training, you're probably also in the BioBlend training. Anyway, we just make sure that we're targeting our API test against the new release. Then we create release notes. This usually falls on the release manager. It's a big process. There's like we automate the sort of curation. We take all of the PRs and we sort of merge them into restructured text file, and we, there's still a lot of like tweaking of that. We've got to merge like PRs that are related into single things. We've got to summarize the big features. We create user and sort of admin developer release notes. One thing you can do if you're opening PRs to Galaxy is make sure that the PR title reads as like a sentence, so as a short sentence describing what's being done for the release notes. So when you're writing that title, you should think about the release manager at that point and sort of say like what would the release note for this PR look like. Yep, and there's the process for committing those. And then when it comes time to do the release, again, this is, May's release, I think, was toward the end of June. We're busy. But there's another set of processes. Again, make sure there are no blocking issues this time and no blocking PRs. So nothing targeting the 2005 branch. I mean, that's sort of when I'm the release manager, that's like my sort of sign that it's time to do the release, is when there hasn't been a new bug fix PR for a while. And I know that irritates some people because it's like, it's been 2 months. Why hasn't there been a release? And in my opinion, like, well, there's still bug fixes streaming in. They're like, if we're still getting a bug fix daily, I don't want to do the release yet. But that means that the release slips. And I think, to me, it's no problem. It's no problem to me if the 2005 release comes out in July. But that does irritate some people. Maybe we should create like a vote on that. Like, as an admin, would you rather have would you rather have those bug fixes still streaming in, but then be able to like plan like, oh, June 1st, I can do the May release? Because I don't know. I'd be interested to see an admin's perspective. But I think some people just think it looks bad on the project that we don't get these things out, quote unquote, on time, even though I don't think of them as late. But yeah, we've got we have on the release a new Docker container. That's Bjorn's Docker Galaxy Stable project. We update IUC and tools dev teams, like, so the big tool repositories, make sure they're testing new tool contributions against the new release. And then we announce the release in various places on GitHub, on our hub, Galaxy Help. Verify that the actual documentation for Galaxy has the new release on it. And then we have presses.
Ali Nematbaksh asks if it's always safe to for the database to upgrade Galaxy in each release with Ansible. And I would say, so our standard line for this is always make sure that your database is backed up. So ours, for example, is continually backed up using the point-in-time recovery system that Postgres provides. But I've never had a problem with it, ever. So, and we upgrade ours using Ansible the same way that we taught yesterday. So hopefully that answers the question. All right, continue on.
Nate, do you know, or does someone know the end time of this? It's 2.5 hours, right? So we've got 2 more hours, right? Probably there'll be a break at some point. Is that okay? And then my last point was organizing issues. Well, not my last point.
It'll be 11:30 our time, so 2 hours exactly.
So if we go back to here, there. Oh, look at that. The issues have a K. There's a lot of issues and a lot of pull requests. And so that's hard to manage. It's an ongoing process. But we do try to use tags to help this. These are maybe, the pull requests are better tags, but we have tags for pull request and issues. And I'll just briefly go over those. Although this, and I'll show you where the documentation for that is also, but.
Hang on 1 sec. So we got another question from Dennis Yuen, who asks, sounds like there's pressing security issues are kept on private on a separate issue tracker, but what about the PRs for fixing the issues themselves?
So we don't.
No, go ahead.
We don't usually issue PRs for that. We'll run that. We'll patch them. We'll make a local change. We'll make a change to our branch and just make sure, we'll run the tests locally and just make sure they're good. And then we will send the patch to people who have public servers a couple days before we actually patch Galaxy on GitHub. And so we do make sure that people who host public servers have access to the patches before we announce the security release. And so there is no PR. There's just patches at that point. And then when it's time to actually patch the repo, like maybe 2 or 3 days after we send it to the public servers, then we just, usually what we do is we just commit it directly. Yeah. Does that answer the question? Okay. Yeah, and so if you're wondering why we have that email address, I mean, that's part of it. We want to make sure that people who are hosting Galaxy publicly have the ability to patch it before we do releases. Oh yeah, I was talking about issues. So here's a list, here's some of the labels. And so they're broken up, some of them are broken up into categories and colors. So the area here refers to the so this area works for PRs into issues, but it could be like, what part of Galaxy it belongs to or references. And there's a bunch. Dependencies is not really used. So then we have different friendliness levels. Help wanted is the easiest set of issues generally. And so if one of the people who have access to the repository think like, oh, this is an issue that is a good place to start working on Galaxy, we'll tag it with help wanted. So we just think like this would be a relatively clean place to start. Like the issues in the code probably shouldn't be too complicated. Now, this is software estimation, right? So sometimes I have seen help wanted issues that I was like, well, I'm certain that's wrong. That is not easy, but we do our best. And then during GitHub's Hacktoberfest, we changed the name of help wanted to Hacktoberfest so people can see it all over the world. But then we also have intermediate and unfriendly if you want a sort of sense of whether this would be a difficult thing to tackle. And if you ever want like us to tag something with the level, then just let us know. There are some existing tags, but I mean, we could sort of do that estimation for you. Invalid, I've never seen that. Then we've got different kinds of issues or different kinds of pull requests, I guess. Cleanup refactoring, this probably shouldn't affect the runtime of the code really. It's just changing either, cleaning up some documentation, refactoring some code. Yeah, and then the next level up is enhancement. So this is actually making some modification. Maybe it's adding a new test. Maybe it's tweaking some UI layout. Maybe it's adding a new backend option. And then past enhancement is feature. I mean, this is adding something new and awesome to Galaxy that really should be at the top of the release notes. And it should be, it's a big thing. It's something we should let people know about, right? Presumably, each time you upgrade Galaxy, you get a ton of enhancements that you don't really care about. But the features probably are things that we want to highlight. And then there's just bugs otherwise. And so those are the kind issues and tags. Major, I don't know that we use major a lot. Minor and merge, though, are interesting because these are, merge means we're like merging the latest stable into development. And so technically we don't even really need a PR for that, but maybe we'll do a PR because we want the CI, we want to make sure that all the continuous integration stuff passes. And so merge and minor are things that we don't put in the release notes. So our release notes process filters these things out. But a minor, something that's labeled minor, doesn't mean, it's not really actually related to the size of the PR. It's a change to something that was added this release cycle. So if we do a big change we add some new big feature this release cycle, and then we follow it up with a bunch of fixes, we probably only need a release note item for the big initial thing. And so we'll tag the follow-up things with minor until the next release. And then probably those should have their own set of like enhancement issues. When I was making the videos, I went through, we have like a policy and stuff around popularity, but we don't actually use it anywhere. Procedures PRs are big, important PRs that need much more than one commit. So these are project governance procedures. And so anything that's labeled procedures needs, it needs a lot of committers to +1 it, and it needs to sit around for at least a week. So that people can see it and have time to comment on it. And so I mentioned that the code of conduct is changing. So Nate opened this PR 5 days ago, and it has all these approves, and we still can't merge it. We got to wait at least a week. But yeah, this is the PR that adds additional reporters to the code of conduct. Yes, thanks again, Nate. So that's an example of that. And then, yeah, the next one, I mean, triage is something that we sort of, our bot will sort of assign a triage to a issue that doesn't have other tags on it. And so or a PR that doesn't have other tags on it. And so it tells someone on the Galaxy project to go through and actually properly tag this pull request. And then work in progress PRs. I mean, I guess we have, GitHub these were introduced before GitHub had drafts. This starts with WIP, and so the bot automatically tagged it with work in progress. or maybe I did. But yeah, if you open a PR with a work in progress start, the bot will tag it with the work in progress. That's issues. Oh, and these are outlined in issues.rst. Oh no, I should have clicked away from that. Yeah, which is just what I just talked about. Okay, so that was a lot of different docs, and they're all tied together on docs.galaxyproject.org. You can see here if you click on the releases here, you get a set of the release notes that we mentioned. All the project governance stuff we talked about are under here. The issue management is under there. Okay. So that's the end of that first section. I don't think I thought it was going to take 35 minutes, so we might not get very far. But they're videos. So now I want to talk about some of the guiding principles of the core code architecture. This is where I sort of get on my high horse for a little bit. So I think there's a distinction between the front end and the back end. So the web UI, and that's because the front end and the back end have different target audiences. So the architecture of the front end aims for consistency and is highly opinionated. And the back end is guided by sort of flexibility and is meant to be driven by plugins wherever possible. So let's go into that a little bit. So the target audience of the front end is a bench scientist. So someone who shouldn't have any necessary knowledge of programming. I mean, it's great when they do. I mean, Galaxy sometimes gets this reputation as like discouraging these things, but we have interactive environments, and we have we're an education platform also. I mean, like we love people who know how to program APIs. We got a great community of programmers, but we're not trying to prevent people from learning how to program. We love people to know how to program, but you know, the target audience of the front end is someone who doesn't necessarily need to know how to program, and so they also shouldn't necessarily have knowledge of what the paths of the system look like. Knowledge of command lines shouldn't be assumed. So it's pretty different than some other platforms like Galaxy. We try to aim for consistent font colors, themable components, but like a theme that is consistent. Yeah, and sort of to drive this consistency, we also have like a set of common widgets that we try to encourage and build up over time. And so everything should be component driven. We should have a common set of widgets, and then things from everything from like generic things like forms and grids to very specific things, tools and histories. Yeah, this is the aspiration. I mean, you can go in and find histories represented different ways in the UI, but we're trying to get away from that. And we always have been, but that's the goal. It's the guiding principle, and it's tied to specific technologies, right? So it's Webpack and Vue.js and UX. You know, it's a lot less pluggable than the back end. So the back end is driven by pluggable interfaces that can be adapted to many different technologies. So we use SQL Alchemy, for instance, to abstract out the database layer. So it allows you to use SQLite or Postgres, MySQL sort of. I don't use MySQL, but like it as a sort of possibility is there thanks to our abstraction layer. We support many different cluster backends and job managers. We support different front-end proxies like Nginx, Apache, as well as different application containers, UWSGI, Unicorn, Paste. We support many different storage strategies and technologies, S3, iRods. We've had people contribute backends that I'd never even heard of, but presumably they work for them. And then those are the big things, but even all the little things are plugin driven. The middleware, the job metrics, tool definitions, how containers are resolved, how tool dependencies are resolved, workflow modules, data types, it's all plugins. And so that might sort of say, like, if you have a system that's entirely plugins, maybe that's difficult to get going with. But another principle of the backend is that it should just work out of the box. And we kind of go out of the way to make that happen. So as just cloning the project down from GitHub and calling run.sh, it should just work and work quickly. So, I mean, Nate spent years on this problem and has done an amazing job making sure that, you don't need GCC on your system to get Galaxy running. So we try to make sure all of our dependencies are available in binary form. And we were doing this like long before it was common in the Python world. And we still go through and we make sure that all of our dependencies are sort of do not require compilation. If you don't have a job manager like Slurm available, Galaxy can act as one. If you don't have an external database server like Postgres, Galaxy will just use SQLite. If you don't have a web proxy, then the Python web server will work directly. So it should just work. This combination of should just work out of the box, but you can use plugins to make sure that it scales and adapts to your platform. It's kind of the driving force behind the backend architecture. So just really to briefly summarize, the Galaxy front end is architected with the bench scientists in mind, first and foremost, whereas the Galaxy backend is architected with administrators in mind, first and foremost. And so that's where that consistency versus plugin nature comes into play. That's principles. Don't know. All right. Files and directories. So I added this section this year. We've not really talked about this in past times we've done this, but I think it's interesting to know what those different files are when you clone down Galaxy, basically. So we talked a lot about the project docs already. We talked about contributing the code of conduct. We also have a license file where we've got an AFL license. We've got a citation file, how to cite Galaxy if you use it. We've got a list of people who've contributed. And then we have a README, obviously. And we talked about issues and organization already. Those are the project docs. Where is the code located? So most of the source code is in lib. This is or client. So lib is the Python client. It's a monolithic Python backend. Most of that backend is in lib Galaxy. So the top level namespace in Python is Galaxy. There's a couple more files that might be of interest. Galaxy X has some code that's used by standalone jobs. And then Toolshed has the source code that powers the Galaxy Toolshed. So this is the sort of traditional view of the Galaxy backend. We also have a version of the Galaxy backend that's decomposed into packages, into smaller pieces that are maybe more easy to make sense of, that we'll talk a little bit about here. But it's the same code. So we'll come back more to that dichotomy. The front end code, the ES6 JavaScript code that powers the web UI, is in client Galaxy scripts. Okay, and so what are the sort of executable scripts you get with Galaxy? Run.sh, we mentioned already, is the script for starting Galaxy. Check it out for different options and stuff. We have a makefile with common deployment and development tasks. So some of the deployment tasks might be like linting your configuration. And some of the development tasks are like those release process things we mentioned, or formatting the client code, or linting the project. Run.tests is meant to be like a friendly wrapper script around a friendly scrapper around running the tests. And so we have a bunch of different tests we'll talk about in different test types. And runtest.sh is, if nothing else, documentation for how to run them. The scripts directory is full of admin scripts, I would say, for the most part, like specific scripts for specific smaller tasks you might use with to do admin-y stuff. A couple of the main ones are Galaxy main is a script in there that's used to run Galaxy without web servers. So we use this, for instance, to run job handlers on usegalaxy.org, I think. So the job handlers don't need a web server, so why run it in UWSGI? And so we could just run this script directly. Another one is PG cleanup. So optimize Postgres commands for managing Galaxy datasets, cleaning up histories, cleaning up datasets. If you've got a big server that you're running over a long amount of time, PG cleanup will be important. I don't cover the admin stuff in here in this talk, but there's a ton of admin training material on training.galaxyproject.org, and we have multiple times a year admin events, like the admin trainings at this conference, but we also have week-long admin trainings once a year. So if you're an admin, definitely check that out. DB Shell is like an interactive environment for exploring Galaxy's database and models against a real database. And so this is kind of like a pseudo Galaxy process, but just one that is for playing with the database. And another script you'll encounter is managedb.sh. It's a script for upgrading and downgrading the Galaxy database between releases. I mentioned tests. We have a lot of them. The client unit tests are in client Galaxy scripts. And they're in 3 places below that. So the newer style tests, we just stick right next to the components we're developing, which is really, I love this. It's really easy to find the test and associate it with the component it's testing. And so those will be in components along with the actual components themselves. Then we have some more suite style tests, Mocha tests and QUnit tests. So the QUnit ones are a little bit older, but still some interesting and useful tests. We're sort of transitioning towards Mocha.
Just to jump in real quick, Pablo Moreno asked if PG cleanup deletes stuff from a file system and deleting linked things from the database. And the answer is yes. When you get to the very end of the process and you're cleaning up data sets and purging data sets, it does remove them from disk.
Thanks. Yes, and keep the questions coming because I'm just like regurgitating what's on videos. So libgalaxy test has like properly packaged Python tests. And so there's a few different directories in here that are interesting. So some base files that are used by many different tests, but then API tests. So this is a suite of tests against the Galaxy API, and then Selenium tests, which are the end-to-end tests that include an automated web browser. So, tests against the API and then tests against the actual like web client and the full experience, including the web server. Tests has like older, not older, has miscellaneous Python tests that aren't like properly packaged yet. And so they have integration tests. So these are like API tests, except for they target custom Galaxy configuration, right? So this API test suite will just target one Galaxy server. It will boot up a server and then run all the tests for all the APIs against it. But a lot of times you want to test a particular configuration of Galaxy. So that's where the integration tests come in. They combine modifying the Galaxy integration with the actual API tests. Integration Selenium is a combination of both the ability to customize Galaxy and the ability to run an end-to-end automated web browser. So the Selenium test, for instance, can't test the FTP file system because they don't have an FTP configured. But there's an FTP test that tests the FTP in the web browser here and makes sure everything is configured ahead of time. And then the unit tests for the Python code in libgalaxy are underneath unit here. And then tox.ini is an entry point for linting and testing Python code. Oh, this is going to be a long day. I'm already winded. Beyond testing, we've got some continuous integration files. Oh, I should have mentioned that when we were talking about pull requests. So our continuous integration, where are they? 14 checks. And some of these checks are very compounded. So for instance, get code and test, the Circle CI tests, have we're linting Python, we're linting JavaScript, we're running unit tests, we're linting our tools. So anyway, all of those green check marks. Oh yeah, I brought this up because frequently there'll be red check marks in here, right? Red X's, and you should think carefully about whether that's related to your code or just noise. And if you have any questions about that, let us know. I detect a lot of stress from new contributors about red X's here when they're like, why is this component that's completely unrelated to my stuff red? And it's because we have so many checks that just, the nature of the universe being noisy is gonna make having all green check marks like this. I mean, this is hard to obtain on the first pass. So frequently the problems won't be yours. And so if you have any stress at all about a red X, let us know, and we're usually pretty good at figuring out if that red X is related to your code or not. Yes, that's continuous integration. Anyway, here's the files that power it. I showed you those Circle CI descriptions. Those are in Circle CI config.yaml. We've got a few different things that run on our Jenkins cluster. That would be like the API tests, the doc tests, framework tests, and Selenium tests. And so those are configured in .ci Jenkins and in the test suite. These are really just wrappers around runtest.sh, but they show how to configure, how to run runtest.sh with like a Docker container inside of a Docker container. And then we have some newer style GitHub workflows. These seem to be very popular. They seem to be more stable, and they're giving us lots of compute, it seems like. So we're doing some busier tests here. But so some of the newer stuff is as GitHub Actions, and those are configured here. I mentioned that there are two different views of the Python files. One is in libgalaxy, and so this is the monolithic namespace. So this is just like all of the Python that makes up the backend is just dumped into libgalaxy. And so to sort of have some examples to work with, I picked out 3 files. There's nothing special about these files. They're just 3 interesting files. Galaxy util init has basically all the little random utilities we use across the project. Galaxy model mapping is the SQL alchemy like mapping between the database and Python objects. And then libweb framework has a bunch of decorators and stuff that sort of power what we might think of as the framework behind Galaxy. So like this is an API endpoint. Make sure that the dictionary gets turned into JSON on the way out. And so these in lib, these files are all together in one big Python namespace. In packages, though, we break them out into packages that we publish to PyPy, the Python package index. And we try to make sure that for each package, we run the tests in isolation, so just against that namespace, and it's annotated dependencies. So we're trying to get a better handle on our dependencies here. And this makes sure that we don't have circular requirements, across, when everything was just libgalaxy, blah, 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 you could have like the models importing web framework stuff and et cetera. We had a lot of circular imports and like crazy imports that, were hurting, I think, the cohesion of the project that I think is being reestablished with these newer packages. So like this file, libgalaxy util init, is in a util package that doesn't have a lot of dependencies and is just like, as a very basic PyPy package. It's got its own Galaxy namespace, and it uses Python namespace packages to sort of establish that, like, when this is used as a package, make sure that my Galaxy namespace gets merged with all the other packages that have a Galaxy namespace. So it's underneath Galaxy util init.py. And this mapping file is in what we call the data package, which we'll talk a little bit more about, but underneath Galaxy model mapping. And then we have a web framework package, which has Galaxy web framework, which is this directory. And so we've got 2 views of the project, and we use symbolic links to sort of establish, just to make sure that they're actually the same physical files. So you don't need to worry which view you're using. Most people develop against libgalaxy still, I think, but as the packages get get more useful and more used in other contexts, hopefully, we will see some development that happens against these packages. But given the symbolic links, hopefully it's all just pretty transparent. I mean, the Galaxy, one of the packages is toolutil, which is used by Planemo and Pulsar, some Galaxy project things, but it's also used by the CWL reference runner, for instance, to do, dependency resolution if you have like CWL software requirements. So this stuff is, it was real use cases that drove us to want to package up parts of the Galaxy code base and let them be reused in other projects. If you used Galaxy Client, oh no, what was it called? It was called Galaxy Lib in the past. This is our sort of alternative to that that's working, I think, a little better. So what are these packages? So like I mentioned, the util package is the package that sort of has the fewest requirements on other packages in the Galaxy ecosystem here. So I sort of root it at the base of the hierarchy here, though. But then it has a few things that depend on it. Containers is not super interesting, but toolutil is. So this is the package that is sort of, it's like what Galaxy Lib used to be, and it is the thing that now is used by the CWL reference runner. It's used by Planemo to parse tool XML files. It's a useful package for tool parsing and tool dependency resolution, for container resolution, so reasoning about biocontainers. I think this package is used by Bioconda even, right, to mull or to build. It might be. I don't know, but stuff like containers and tools. There's a lot of utilities in there. Object store is another interesting package that you might want to sort of, if you are looking at a Galaxy object store and think, well, that's an interesting abstraction I might want to sort of develop or hack on independently or reuse in a project. All it really depends on is util. Data is a combination of a few different things, but it's the Galaxy models. So the things that talk to the database directly. It's the Galaxy data types. If you're developing custom data types, those will be in here. And then some other like smaller utilities that were sort of so interdependent that I couldn't isolate them. So security stuff, like ID encoding, and then data collection stuff, which the data collection stuff sort of makes sense. But that's all processed in data, packaged up into data, which depends on object store. WebStack is our sort of integration layer with UWSGI or like, application messaging. And then the framework piece is that next level above. That's like our actual decorators and stuff, the things that are actually used by our controllers to describe to piece together a web framework. I'll talk a lot more about the web framework coming up. And so that depends on data and WebStack. Job execution depends on data, and this is what Pulsar uses, can optionally use to sort of run remote Galaxy metadata detection. So this just sort of extends that data concept with Galaxy's metadata concepts. We have an auth component that and no one's using it yet, but it's it's like a standalone thing. It's a pluggable architecture for auth, right? So you could potentially reuse this in another project. And then we have app, which is all of this stuff. Well, not Selenium, but all of the rest of this stuff grouped together, and it's the whole backend minus the web components. So we mentioned Galaxy main running Galaxy without the web server. Presumably that could belong to app, and all of its dependencies should be at this level or lower. These last couple levels up here are not things that we've done a great job of packaging on PyPy and testing them there yet. We're sort of slowly building from the base up. So I think I published app, but it probably doesn't have all of its requirements correct or something like that. But that is that. And then so the web apps sits on top of app, and that adds the controllers and stuff. We'll talk about the controllers coming up here, but it's that web layer. The testing. We've got two sort of base test packages. The driver, which depends on web apps, so it can actually launch a Galaxy server to run tests. But we also have test base, and so you can run the Selenium tests and the API tests without the test driver and just sort of target an existing Galaxy server. And so in that usage case, in that usage, you don't really need all this junk, right? You need tool util because you need to be able to run tool tests. And it does some client like request handling. But yeah, that is the new package structure. Any questions about that? All right, here's the Galaxy tool util package that I mentioned on PyPy, just as an example. What do these packages look like? I like how I wrapped up that section, and then I have more slides on it. So it's got a setup.py, so it's the boilerplate project definition for Python packages. It's got its own make file for publishing and linting and stuff. It's got that namespace package definition I mentioned. So this file right here is what says, yeah, I'm publishing a Galaxy package, but it's a namespace. So just put it with any other tools any other packages that are publishing to this namespace, just merge them together. And then we sort of load the metadata automatically in setup.py from a file that is based on the name of the package. And so this is for like reducing code duplication and stuff. And then tool util itself is a symbolic link. And the tests themselves are symbolic links back to the monolithic project. Okay, so that's the logical structure and the files and directories of the Galaxy project. All right, web frameworks and architecture, the architecture of an interaction. So there are, in the web client video, which I don't think we'll get to today, but like I described like 4 different like rewrites of the client, right? And so we're in the middle of, I think, rewrite number 4 that I'm aware of, at least. There's probably, well, yeah, no. There's rewrites that predate that, but.
Hey. Peter Van Hoysten asks if pip install XYZ or conda is going to replace git clone at some point in the future as the way to install Galaxy.
Yes.
Yeah.
But
it will.
One of the goals, right?
Yeah.
But we're not there. I mean, we perpetually think it's a month away for the last 4 years. So
We made progress during the CoFest last year on it, but
I mean, I think we've made consistent progress. Like,
yeah.
I think that Nate wants it packaged up, and I want the packages to be cohesive and the requirements to be correct in the namespaces. And so, like, I've made Nate's job a lot more difficult by sort of decomposing it. But
thanks for admitting it.
Yeah, no, of course. Yeah. I frequently my whole job is to make Nate's job more difficult. Yeah. So I think even after we make the packages available, it's not like we're gonna like get rid of the git clone method right away, right? Because that's how all the developers run the code. I think run.sh will exist well past the time that those packages are like the best practice. And I don't think those packages will be the best practice this year. So it's not something to necessarily, as an admin, to put on your roadmap and say, well, in November, I'm gonna rewrite our infrastructure to use pip. I wouldn't worry about that. Thanks for the question. So we have many different frameworks and places where the browser and the server interact. But I just want to sort of I have a diagram for just what would be like the best practice typically for a component right now. So you land on a Galaxy page and you make a page request, and what you get back is static content from the server, HTML, JavaScript, CSS. And that set of content is used to build up components in Vue.js. And then Axios is the client we use in JavaScript to query the API. And so the client will figure out which APIs it needs to talk to and make requests. And so it makes API requests in JSON to the server, and the Galaxy server, the API controllers, build up a JSON response and give it back to the browser. And then in some cases, those responses are stuck in a Vuex store. In some more typical cases, those components just consume the API directly and render the UI that they need to render using Vue.js templates, typically. So this is like the current rewrite, so the thing we're on right now, our current way of doing it. But then there's bits and pieces of different code all over the place, right? So there's plenty of places where it's jQuery querying this and building the component, you know, with a backbone view, or there's other places where we actually render HTML using Mako on the client or on the server, and just, you know, are sending that right to the browser. But this is, anyway, this is like the future. This is what we're doing right now. And so this is the sort of central, the two kinds of major requests. But let's take those requests and sort of build out what the backend looks like in both cases. So we're expanding the right side of this diagram. And in this case, we don't have a proxy. I want a separate version of this diagram with the proxy, but it's fine. So in this case, the WSGI server is typically going to be UWSGI. And for the static content, the CSS, JavaScript images, it just serves those directly back. And so it never touches what I would call the Galaxy backend up here. Can you guys see my mouse? I'm probably moving my mouse all over, and it's not mattering, huh? Anyway, when you
no, you can see it. That's fine.
Oh, okay, awesome. But for the API request, a lot more happens here. We've got the TCP. Yeah, so we've got the request that comes to the web server, and what does the web server do? Yeah, we'll walk through the different individual layers, but at a high level, what the web server does is it builds a WSGI environment and it hands it off to the middleware. And the middleware modifies the WSGI environment in many different ways. Many different middleware sort of handles it not recursively, but in sequence. And then once it's done, once the middleware has acted, it takes the modified WSGI environment and hands it off to the web application. And at this point, we're talking about actual, what I would call Galaxy backend code. And what the web application does is it builds this payload object and this Galaxy web transaction object that we're going to call trans in the code, and here just called trans. And it hands those off to a controller method. The controller method has a bunch of logic in it. For the most part, all right, so what I'm going to present here is, again, the best practice, but there's plenty of places where the controller just does something directly and then sends it back. But hopefully, as we're going forward, the typical case is to just handle the web aspects of the request. So just turn the payload into Python objects. Like, figure out how you can take the web out of it and turn it into like a business logic action, and then hand it off to a manager. And the manager is going to be the layer that sort of does not depend on web stuff, and just knows how to deal with Galaxy components and Galaxy models and piece them together to like do an action. And so it makes all sorts of Python function calls. I mean, all of the complexity is past here, really. But the manager sort of orchestrates all of that and gets some Python objects back. The controller is responsible for making those dictionaries, essentially, and handing them back as JSON, which eventually come back to the WSGI server as a stream of bytes, and then out back to the browser. So the next few slides are going to be a bigger description of each of the individual layers here. Oh, the WSGI layer. So this is a Python interface for web servers defined by PEP333. Here's a link. Galaxy tends to favor UWSGI, but other options such as Unicorn and Paste are available. And here's some links. I said stuff on the video that I'm afraid to say with Nate sitting in the room with me, but I'll just say that UWSGI has like a lot of bells and whistles, and so it's very highly performant and a lot of different configuration options, but can sometimes be a bit brittle. So yeah, for like simpler deployments or simpler like programmable applications, maybe these are better choices. So that's the web server layer, excuse me. Then we have the middleware. So this is an interface defined by the WSGI standard, and it's just a function essentially. I mean, you're given an environment and a method to start a response, and it acts on that environment. So it filters, it modifies the environment, and passes it through to the next layer of middleware, and then eventually to the web application. Galaxy uses several middleware components, and they're defined in Rapid Middleware in Galaxy Web Apps, Galaxy Build App. So that's where that's defined. Yeah, and here's some examples. This one handles, like, turns exceptions into WSGI exceptions. Remote user is used to, if you've got a proxy, for instance, that's doing the authentication, like you're having Apache or Nginx do the authentication of your users, remote user is the middleware layer that Nginx can set up the environment for and then pass it off to this. And so it establishes the Galaxy user for the web request here. I'm explaining that poorly, but the code actually is relatively straightforward. Sentry, if you have it configured, is set up here. So that's like error logging for the web server. If you're collecting metrics with statsd, that's configured here. So these are probably not too interesting. And that's the middleware layer. So as you can sort of tell, it's not like these are not things that are tied to like specific Galaxy like logic, right? It's just things that you do to every request. But then you get to the web application, which is a little more interesting. Okay, so yes, we have this Galaxy web application, which is the actual. It's a weird place for this. All right. The web application is like an implementation of a framework, and it's a collection of controllers and routes and how to handle the request. And it's the endpoint that the WSGI standard talks to. And so ours is Galaxy Web Application in Galaxy Web Apps Galaxy. But it's an implementation of some framework stuff, including what I would call a Galaxy Web Application instead of the Galaxy Web Application. But a Galaxy Web Application, the framework is here in base web app. And it has, one of the things it does is it establishes a web transaction. And so that's that trans object. And so it's the thing that wraps up basically a description of the request and the context of the request, what user's making it, et cetera. And so those two things happen in this package, and they're both like Galaxified. They've got some Galaxy logic that uses Galaxy models and stuff, but the sort of the framework piece that's not tied to the Galaxy's models and internal logics and structures are in Galaxy Web Framework base, right? So these are just sort of the establishment of a very generic web framework, essentially, sort of mini Django. Nothing like Django, but I mean, it's the idea there where you don't, this framework code doesn't have any sort of knowledge of Galaxy's internals. So that web app, like we said, it talks to trans, it establishes the trans, and then it also has an app object, which is like a big global Galaxy object that has all the different Galaxy web components, not web components, all the different Galaxy backend components sort of hanging off of it. And so this app is a tiny little box here, but it's the biggest thing on the Galaxy backend. But the web app has the controllers, the API controllers. It has a mapper that we'll talk about here. It's got the thing that builds the transaction here. And then it has this handle request is what WSGI uses. And it's the WSGI endpoint. We'll go through handle requests coming up here. But first, before we get to the handle requests, we got to talk a little bit about the mapper that we use. So we use the routes package to map. So it's a pretty standard web framework routing engine. Here's an example where we say we're going to add a route, and this is not quite a regular expression, but sort of like a regular expression. And you can sort of see here, well, data sets is fixed. So if we hit the web, if we hit the Galaxy application data sets, and then there's an ID that we're going to parse out, that the routes will parse out for us, and then we go to display, and then we find a file name. Then what we're going to do is we're going to route that request to the dataset controller. We're going to use the action display. So action here is a method on that controller class. And then we're sort of going to default dataset ID and file name here to none, but these are things that will parse out of the description of the route. So then when you actually hit the URL, looks up the controller name dataset, finds the method name display, and uses that. And so that's all done inside of handle request. And so this is the very sort of top of the web framework. And it's pretty simple and kind of beautiful. So it's worth, I don't know, I'll talk about it. The slides, I'll talk about it. But anyway, the path info is basically the URL that's being requested, but it's the end part of the URL, the part that we care about. And so we get that from the WSGI environment. We look at the mapper we've established in the web framework, and we get this map object. We got a couple different kinds of controllers. This code's a little bit old. We also have client controllers now also. We build that trans that we keep talking about, and you'll see throughout the code base. But then we use this map to pop off the controller, which is a name. And then we use the controllers that are, that are attributes on this web application, Galaxy web application object. And so we get a controller, which is a class. Well, it's an object, excuse me. It's an object that was instantiated. Then we get the action name. And then we sort of use getattr, the Python, this is basically Python dynamic code thing that says on this object, get that attribute or none. And so it gets that action, which is a method on that controller. So you get a method back. And so now this is action was a string, and this is the method. And we build the keywords that we're going to send to that method. And then the actual response is just calling that method with our transaction and the keywords we built up from the request. So this is the framework that powers Galaxy. And I think probably a common question we've gotten in the past is why not just use Django? And there are a lot of standards we're building on here and concepts and libraries that are used in other web frameworks, but we have our own. And the answer is just that it's old. Galaxy's 15 years old at this point. Django didn't exist when we started. The Galaxy community does use Django for other things. If I was starting Galaxy from scratch, I would probably use Django if I was going to use Python at all. But we've just simply predated it, and there's too much existing stuff there, and it's all pretty simple. So there's not a huge pressure to migrate. And that's why we don't use Django. But we love Django. And in the ecosystem project talk that I skipped, I cover some projects that do use Django. All right. We saw those list of controllers on the web application object. The most interesting ones are the API controllers, and those are in libGalaxy Web Apps, Galaxy Controllers API. The exposed methods there, like we saw, they all get passed trans as the first object, and then the request parameters. And these are ideally thin things. So they should be focused on doing webby things, like parsing the request into Python objects, which you keep saying, and then handing the business logic off to a component that's not tied to the web server. Generally, those are managers, but even if it's some other component, it's still ideal that these things are as thin as possible. We've got some legacy controllers that some of them actually return HTML and stuff. Yeah, but there's fewer of these, and they're decreasing over time. For the ones that do return HTML, usually it's via Mako templates, and these are in the templates directory on the top of the project. If you find yourself in the templates directory, hopefully you're not doing a ton of work there. Hopefully you're just, it's a bug fix. But if you're doing enhancements, probably best to rewrite it in JavaScript. And that is the web request. Wait, so we have an hour and 10 minutes. Maybe we can take a 10-minute break at this point. Is that fair? Let's take a 10-minute break. I will be back in 10 minutes. No objections.